Welcome to Animal Uncovered, the podcast where we explore the most unbelievable life cycles in the natural world. From the moment life begins to the moment it ends, nothing is as simple as it seems. There are places on Earth where light has never reached, where the pressure would crush a human chest in seconds, where the cold is so absolute that metabolism itself must be reimagined. And in these places, among the most hostile environments our planet can offer, lives an animal so large, so strange, and so thoroughly hidden from human eyes that we've never seen one alive in its natural habitat. The colossal squid, Mesonica teuthis hamiltoni, a name that means middle claw squid, though there is nothing middle about it. This is an animal that can grow longer than a telephone pole, with eyes the size of dinner plates and hooks that rotate on its limbs like the claws of a nightmare. It inhabits the lightless depths of the Southern Ocean, circling Antarctica in water so remote that most of the planet's surface is closer to outer space than to where this creature hunts. We have found fewer than 24 specimens. Most arrived as fragments in the stomachs of sperm whales, or as battered carcasses hauled up in fishing nets, already dead, already dissolving. The largest intact specimen ever recovered was caught accidentally in 2007 by a New Zealand fishing vessel working the Ross Sea. It weighed nearly 500 kilograms and measured over 4 meters long, though its tentacles had been damaged. Scientists estimate it was not fully grown. Everything about the colossal squid resists easy understanding. Its life cycle unfolds almost entirely beyond the reach of submarines, cameras, and human observation. What we know has been assembled from accident and inference, from the marks left on whale skin and the chemistry of tissues preserved in ice. This is a creature defined as much by absence as by presence, and yet, even in fragments, its story is extraordinary. This is the life cycle of the colossal squid, a story that begins in darkness and ends in darkness, and everything between remains largely a matter of educated conjecture. Part 1. To understand where the colossal squid came from, we must first understand what it is. Cephalopods, the group that includes squids, octopuses and cuttlefish, have been evolving for over 500 million years. They are mollusks, related distantly to snails and clams, but the resemblance is nearly unrecognizable. Where other mollusks grew shells for protection, cephalopods largely abandoned them. They invested instead in speed, intelligence, and an almost unsettling degree of neural sophistication. Squids, specifically, emerged as one of the most successful branches of this lineage. They are built for pursuit. A muscular mantle acts as a jet engine, drawing water in and expelling it with force. Tentacles studded with suckers or hooks allow them to seize prey in the open water column, and their eyes, among the largest and most complex in the animal kingdom, allow them to see in conditions where most creatures are functionally blind. The colossal squid represents the extreme end of this evolutionary path. It belongs to the family Cranchidae, the glass squids, most of which are small, translucent, and drift passively in mid-water. But Mesonica teuthis broke from this pattern. It became massive, it became muscular, and it descended into the coldest, darkest waters on Earth, the deep layers of the Southern Ocean that encircle Antarctica like a frozen moat. This ocean is not like others. The Antarctic circumpolar current is the largest ocean current on the planet, moving more water than all the world's rivers combined. It isolates Antarctica thermally and chemically, creating conditions of profound cold and biological scarcity. The surface freezes for much of the year. Below, in the mesopelagic and bathopelagic zones, temperatures hover just above freezing. Pressure increases by 1 atmosphere for every 10 meters of depth. At 1,000 meters, the pressure is 100 times what it is at the surface. At 2,000 meters, it is 200 times. The colossal squid lives somewhere between these extremes. Most evidence suggests it occupies depths between 1,000 and 2,000 meters, though it may venture shallower at night and deeper during the day. This is the twilight zone of the ocean, a place where even the faintest surface light is absorbed entirely. Bioluminescence becomes the only source of illumination. Prey is sparse, energy is precious, and the squid that survive here must be built not for abundance but for endurance. Part 2. Reproduction in the colossal squid is one of the great unknowns. We have never observed mating. We have never seen eggs in the wild. What we know comes from anatomy and comparison to related species. Like all squids, the colossal squid is semiparous. It reproduces once at the end of its life, and then dies. This is not a gradual decline. It is programmed senescence, a biological switch that diverts all remaining energy toward reproduction and then shuts the animal down entirely. For creatures living in such an energy-poor environment, this strategy makes brutal sense. There is no surplus for a second chance. Males produce spermatophores, packets of sperm encased in a gelatinous sheath. These are transferred to the female during mating, though exactly how this occurs is uncertain. In many deep-sea squids, males use a specialized arm called a hectocotylus to place spermatophores inside the female's mantle cavity, or attach them to her skin. In the colossal squid, the hectocotylus is present, but its use has never been witnessed. What we do know is that the female's reproductive system is enormous. Dissections of mature females have revealed ovaries weighing several kilograms, filled with thousands of eggs. Each egg is small, perhaps a few millimeters in diameter, and encased in a tough, transparent membrane. This suggests that the colossal squid, like many other deep-sea squids, releases its eggs into the open water rather than guarding them or attaching them to a substrate. The eggs are believed to be neutrally buoyant, drifting in the water column as they develop. This is an ancient strategy, one that trades parental care for dispersal. The eggs are on their own from the moment they are released. Most will be eaten. Most will drift into zones where temperature or pressure prevents hatching. But some, a tiny fraction, will survive. Development likely takes weeks or months slowed by the cold. In related species, embryonic squids can be seen moving inside the egg casing, flexing their mantles, preparing for the moment of hatching. When that moment comes, the young squid breaks free into a world of near total darkness, alone and already hunting. Part 3. A newly hatched colossal squid is almost unrecognizable compared to the adult. It is tiny, translucent, and utterly vulnerable. The mantle is only a few centimeters long. The tentacles are thin and uncoordinated. The body is filled with a gelatinous substance that provides buoyancy without the need for a swim bladder, which would collapse under deep-sea pressure. This is the paralarval stage, a term scientists use for squid young that are still developing the features of adulthood. Paralarvae are drifters. They lack the muscle mass to control their position precisely, and so they rise and fall with the currents, feeding on whatever microscopic prey they encounter. Copepods, tiny crustaceans smaller than a grain of rice, are the likely staple. The squid uses its tentacles to snatch them from the water, drawing them toward a beak that is already razor-sharp despite its size. Growth is rapid. Squids are among the fastest-growing animals on Earth, their bodies composed largely of protein with minimal skeletal structure. In warmer waters, some squid species can grow several centimeters per month. The colossal squid, living in colder conditions, likely grows more slowly, but the principle remains. Every meal is converted almost directly into tissue. The mantle elongates, the tentacles thicken, the eyes enlarge. As the squid grows, its behavior begins to change. It becomes a more active swimmer, no longer content to drift passively. The mantle muscles develop strength, allowing for controlled jet propulsion. The arms and tentacles gain coordination, and the suckers that line them begin to harden, developing into the tools that will define its adulthood. But the most dramatic change occurs in the tentacles. In most squids, the tentacles are equipped with suckers lined with chitinous rings, useful for gripping slippery prey. In the colossal squid, these suckers are augmented by hooks, sharp, curved, swiveling hooks that can rotate 360 degrees. These are not just passive grips, they are weapons. The hooks develop gradually, starting as small, calcified structures embedded in the sucker rim. As the squid matures, the hooks grow larger and more sophisticated. In adults, the largest hooks can be several centimeters long, resembling the talons of a predatory bird. They are used to pierce flesh, to hold on to prey that would otherwise escape, and perhaps to fight off predators or rivals. Juveniles, equipped now with these developing tools, begin to hunt more aggressively. They descend deeper into the water column, following the vertical migration of prey species that rise toward the surface at night and retreat to the depths during the day. This is the rhythm of the deep ocean, a daily cycle driven not by sunlight, but by predation and safety. The squid's diet expands. It begins to target larger prey, small fish, other squids, anything it can overpower, and as it grows, it sinks deeper, its increasing mass pulling it toward the abyssal plains where the largest prey and the greatest dangers await. Part 4. By the time the colossal squid reaches adulthood, it has become a fundamentally different organism. The translucent body of the paralava has been replaced by a dense muscular mantle capable of explosive acceleration. The tentacles, once delicate, are now powerful enough to restrain prey many times the squid's weight. And the eyes, those enormous, unblinking eyes, have become perhaps the most sophisticated visual organs in the deep sea. Each eye can be up to 30 centimeters in diameter, larger than a human head. This is not an accident of scale. In the deep ocean, where light is almost non-existent, the ability to detect even the faintest bioluminescent flicker can mean the difference between eating and starving, between escaping and being eaten. Large eyes gather more photons, they provide better resolution at greater distances, and in a predator that relies on ambush and sudden strikes, vision is everything. The structure of the eye is equally remarkable. The lens is enormous, nearly spherical, optimized for gathering light rather than focusing it sharply. The retina is packed with photoreceptor cells, and behind it lies a reflective layer called the tapetum, which bounces light back through the retina for a second chance at detection. This is the same adaptation found in cats and nocturnal mammals, but taken to an extreme. What the colossal squid sees we can only guess. Bioluminescent flashes from prey. The silhouettes of fish backlit by faint downwelling light. Perhaps the disturbances in the water caused by movement, rendered visible by the scattering of bioluminescent plankton. It is a world of hints and shadows, and the squid is built to read them. Then there are the hooks. Fully developed now, they line the arms and the two elongated feeding tentacles. The tentacles themselves can extend rapidly, shooting out like a harpoon to seize prey at a distance. Once contact is made, the hooks rotate inward, driving into flesh and locking the prey in place. The squid then draws the tentacles back, pulling the prey toward the arms, which wrap around it in a tightening embrace. The beak, A structure made of chitin, harder than most metals, shears through muscle and bone with ease. But perhaps the most unusual adaptation is one that cannot be seen from the outside. The colossal squid's tissues are saturated with ammonium chloride, a compound that is lighter than seawater. This provides buoyancy without the need for a gas-filled swim bladder, which would be useless at such depths. The downside is that ammonium chloride is toxic in high concentrations and gives the squid's flesh a distinctly unpleasant taste. This may be a defense mechanism, a way of discouraging predators. Sperm whales, which regularly eat colossal squids, seem unbothered. The squid's mantle is also unusual. In most squids, the mantle is relatively thin, optimized for speed and efficiency. In the colossal squid, it is thick and muscular, suggesting an animal built for power rather than endurance. This is not a pursuit predator. It is an ambush hunter, capable of short, explosive bursts of speed, but likely unable to sustain a chase over long distances. All of these adaptations point to a single conclusion. The colossal squid is a predator of the deep midwater, hunting in darkness, conserving energy, and striking with overwhelming force when opportunity presents itself. Part 5. An adult colossal squid hunting in the Southern Ocean is a creature operating at the edge of what biology allows. The water is near freezing, typically between -1 and 2 degrees Celsius. Metabolic processes slow. Movement becomes expensive. Prey is scarce and scattered across vast volumes of water. To survive here, the squid must be patient, efficient, and opportunistic. Most of what we infer about its hunting behavior comes from stomach contents and scars on predators. Colossal squids eat fish, primarily toothfish, and other deep-sea species that inhabit the same depths. They also eat other squids, including smaller members of their own species. Cannibalism is common in cephalopods, particularly in environments where food is limited. The hunt likely begins with detection. The squid drifts in the water column, motionless or nearly so, conserving energy. Its enormous eyes scan the darkness for movement, for the faint glow of bioluminescence, for anything that suggests prey. When something is detected, the squid does not immediately pursue. It watches, it calculates, it waits for the optimal moment. Then, in an instant, the tentacles shoot forward, the hooks lock into flesh, the arms wrap around the struggling prey. The beak begins its work, slicing through tissue and delivering chunks of meat to a radula, a tongue-like organ covered in backward-facing teeth that pulls food toward the esophagus. Digestion in squids is efficient but constrained by anatomy. The esophagus passes through the center of the brain, a bizarre evolutionary quirk that limits the size of food that can be swallowed. Large prey must be dismembered. This takes time and energy, but for a predator of this size there is no alternative. The squid's primary threat, perhaps its only consistent threat, is the sperm whale. These marine mammals dive to extraordinary depths, sometimes exceeding 2,000 meters, in search of squid. The colossal squid is a favored prey item, and the evidence is written on the whales themselves. Circular scars left by sucker rings and hooks cover the skin of many sperm whales that hunt Antarctic waters. Some scars are enormous, suggesting encounters with truly massive squids. These confrontations are not one-sided. A colossal squid caught by a sperm whale does not go quietly. The hooks tear into the whale's tongue and throat. The tentacles wrap around the whale's jaw. There is evidence of squids injuring whales seriously enough to leave permanent scars. But the whale, with its size, intelligence, and echolocation, almost always wins. When the squid is caught, the whale does not swallow it whole. It crushes it with its teeth, breaking the squid into manageable pieces. The beak, too hard to digest, is often regurgitated or passed through the gut. These beaks accumulate in the whale's stomach, and scientists have used them to estimate the size and age of the squids consumed. Some beaks suggest squids far larger than any specimen we've recovered intact. For the squid that escapes, life continues in the cold and dark. It grows, it hunts, and eventually it reaches the end. Part 6. We do not know how long a colossal squid lives. Estimates range from 5 to 10 years, based on growth rings in statoliths, tiny calcified structures inside the squid's head, analogous to the ear bones of fish. These rings are thought to form daily, and counting them provides a rough age estimate. But the method is imperfect, and the data is limited. What we do know is that squids grow quickly and die young compared to many other animals of comparable size. A sperm whale can live for 70 years. A colossal squid, even at the upper end of estimates, lives for a fraction of that. This is the cost of their reproductive strategy. They invest everything in rapid growth, a single explosive reproductive event, and then they are done. As the squid approaches maturity, its body begins to change. Energy that was once devoted to growth is redirected toward the development of reproductive organs. The ovaries or testes swell. The squid stops eating or eats very little. Its muscle mass begins to degrade, metabolized to fuel the final act. When the time comes, the squid ascends or descends to the appropriate depth, seeking out others of its kind. How they find each other in the vastness of the Southern Ocean is unknown. Chemical signals, perhaps. Sound, though squids are not known to vocalize, or simply chance, squids drifting through the same corridors of deep water until they cross paths. Mating occurs. The male transfers his spermatophores. The female stores them, using them to fertilize her eggs internally. Then she releases the eggs into the water, thousands of them, drifting away into the darkness. And then she dies. Not from injury or predation, but from the simple fact that her biology has reached its end. The same is true for the male. Once reproduction is complete, there is nothing left. The body begins to break down. The squid sinks, or is carried by currents, until it settles on the seafloor, or is consumed by scavengers. This is the fate of all squids. A life lived at extraordinary speed, ended by a biological timer that cannot be reset. For the colossal squid, an animal that may weigh half a ton and span the length of a bus, it is a strangely abrupt conclusion. Part 7. If the colossal squid is difficult to study in life, it is almost impossible to study in death. The deep sea is a graveyard, but one where evidence rarely accumulates. Bodies that sink to the ocean floor are consumed by hagfish, crabs, and bacteria within days or weeks. Beaks and statoliths may persist, but they are small and easily scattered. Most of what we know about the colossal squid comes from fewer than 24 specimens, almost all of which were already dead or dying when found. The first confirmed specimen was discovered in 1925, recovered from the stomach of a sperm whale caught off the coast of the South Shetland Islands. For decades, this was the only evidence that the species existed. Since then, other specimens have been found. A few washed ashore in New Zealand and South America. Several were caught accidentally in deep-sea fishing nets targeting toothfish, a commercially valuable species that shares the colossal squid's habitat. In 2003, a complete specimen was caught near South Georgia Island. In 2007, the largest known specimen was hauled up in the Ross Sea, still alive but dying rapidly in the warmth and pressure change of the surface. This last specimen was frozen and transported to New Zealand, where it was eventually thawed and dissected in a public event. Scientists measured every part of the animal. They examined the hooks, the eyes, the beak. They analysed the tissue chemistry, looking for clues about metabolism and buoyancy. But even this, the most complete examination of a colossal squid ever conducted, left more questions than answers. We have never seen one hunt. We have never seen one mate. We do not know how deep they go or how widely they range. We do not know how many exist. Population estimates are impossible without basic data on distribution and density, and that data does not exist. What we do know is that the colossal squid is rare, at least in terms of human encounters. Fishing vessels working Antarctic waters may spend years without catching one. Sperm whales, on the other hand, seem to encounter them regularly, suggesting that the squids are more common than our limited sampling suggests, simply living in places and at depths we rarely access. This rarity, or perceived rarity, adds to the squid's mystique. It is easy to imagine it as a monster, a kraken lurking in the abyss. But the truth is likely more mundane. The colossal squid is not hiding from us. It is simply living where we are not. Part 8. In the ecosystem of the Southern Ocean, the colossal squid occupies a role that is both critical and poorly understood. It is a mesopelagic predator, feeding on fish and smaller squids, and in turn being fed upon by sperm whales and possibly other large predators. This places it in the middle to upper tiers of the deep-sea food web, a position of significant ecological leverage. Energy in the deep sea is scarce. Primary production, the conversion of sunlight into organic matter by phytoplankton, occurs only at the surface. For deep-sea organisms to survive, this energy must be transferred downward, either by sinking particles of dead plankton and fecal matter, known as marine snow, or by the vertical migration of animals that feed at the surface and retreat to depth. The colossal squid participates in this energy transfer in both directions. As a predator, it consumes fish that have themselves fed on smaller organisms, concentrating energy up the food chain. As prey, it delivers that energy to sperm whales, which surface to breathe and may eventually die and sink, returning nutrients to the deep. But there is another role the squid plays, one that is less visible but equally important. By hunting fish that might otherwise deplete populations of smaller prey, the colossal squid acts as a regulator, maintaining balance in a system where imbalance can be catastrophic. This is the function of apex and near-apex predators in every ecosystem. They are not just consumers, they are architects of stability. The loss of such predators, whether through overfishing, climate change, or other disruptions, can have cascading effects. Fish populations explode, then crash. Prey species decline. The entire structure of the ecosystem shifts into a new, often less stable configuration. We have seen this pattern repeat in oceans around the world. Whether the colossal squid is currently threatened is unknown. We do not fish for them directly, but they are caught as bycatch in toothfish fisheries, and climate change is altering the temperature and chemistry of the Southern Ocean in ways we do not fully understand. Warmer water, acidification, and changes in prey availability could all impact squid populations. But without baseline data, we cannot measure the change. What we can say is that the colossal squid, like all deep-sea organisms, exists in an ecosystem that is far more fragile than it appears. The deep ocean is not a static, unchanging wilderness. It is a dynamic system, tightly connected to surface processes and increasingly affected by human activity. Part 9. There is something humbling about the colossal squid. Not just its size, though that is remarkable, not just its adaptations, though they are extraordinary, but the simple fact that an animal this large, this complex, this successful, can live an entire life cycle almost entirely beyond our ability to observe it. We have mapped the surface of Mars in greater detail than we have mapped the floor of the Southern Ocean. We have sent probes to the edge of the solar system, but we've explored less than 1% of the deep sea, and in that vast, dark, cold expanse life continues, indifferent to our ignorance. The colossal squid is born in darkness. It grows in darkness. It hunts. It mates. It dies in darkness. What we know about it comes from accidents and fragments, from the scars it leaves on whales and the specimens that wash ashore by chance. We have never seen the full arc of its life. We may never see it. And yet, even in absence, the story is there, written in the structure of its eyes, evolved for a world without light, in the chemistry of its tissues, optimized for extreme pressure and cold, in the hooks on its tentacles, designed for prey we can only guess at. The life cycle of the colossal squid is not a mystery because the information does not exist. It is a mystery because the information exists in a place we cannot easily reach. This is the reality of life on Earth. We share this planet with millions of species, most of which we will never fully understand. Some, like the colossal squid, live in environments so extreme that simply reaching them requires technology at the limits of engineering. Others live in plain sight but reveal nothing of their inner lives. The colossal squid reminds us that the unknown is not a failure of science. It is a condition of existence. There are things we will learn, given time and effort and resources, and there are things that may remain forever just beyond our grasp, glimpsed only in fragments, inferred from shadows. Somewhere in the Southern Ocean, right now, a colossal squid is hunting. Its eyes are open in the darkness. Its tentacles are poised. It is living a life we cannot see, governed by rhythms we do not understand, part of a story that began millions of years ago and will continue long after we're gone. We're not the center of this story, we're barely a footnote, and perhaps that is the most extraordinary thing of all. If you enjoyed this episode of Animal Uncovered, following the podcast is the best way to support the show. And if there's an animal you want us to uncover next, leave a review or comment and let us know. Until next time.